All right, I want to spend some time to welcome you all to the Cluster API deep dive. We talked about Cluster API for the past days with a lot of people, and we've seen such great interest and such good questions from all of you. So who are we? I'm Vince. We probably met, and if we're not, nice to meet you all. I work at VMware, and I primarily work on Cluster API. So I'm one of the core maintainers for the project.
I'm Ashish. I work for Salesforce, but I am a community contributor to Cluster API.
A little bit on the agenda. We're going to do an overview of the project. Then Ashish here is going to go through a walkthrough of the V1 Alpha 2 types, the architecture of the project so that you can visualize it. We're going to do a quick demo, and then we're going to go through what's next and the planned features for V1 Alpha 3 and also going forward. And more importantly, we can also go on in points on how you can get involved. We need a lot of help to mature the project, and we would like to welcome you all to our weekly meetings and things like that. So quick overview. Before I go into why Cluster API, people ask me how you would define very easily Cluster API, and the thing that I say the most is imagine GKE, imagine EKS or AKS, but across all of the cloud. Imagine all of these things, put Kubernetes in it, of course, sprinkle a lot of YAML, and you have Cluster API, where you have a declarative spec that you can then manage your clusters in any cloud. The motivation behind this project, we started this project a few years ago, and really Cluster Lifecycle Management is very difficult. We have a lot of tools out there. We have an ecosystem that's very fragmented. You can think about how many times you have found a new tool throughout your day that does spin up clusters, right? There are a lot of them, and you might have to pick one, but then a lot of times, we heard, this doesn't fit business purposes, and companies end up building their own internal tools. So you have an exponential growth of tools that manage cluster lifecycle. And on top of all of that, you need a lot of people to manage clusters. You need people to maintain, you need people to upgrade, and build on top of it. And so we're trying to solve this problem, and we're trying to make it really, really boring. That's something that I like to say a lot, and I'll probably say it tonight a lot. We want to make cluster lifecycle management boring so that everyone, expert or not, can use Cluster API's building blocks internally or whatever you want to create your Kubernetes clusters. And this other point, difficult to build higher order functionality. I've seen teams spend hours and hours to kind of tackle security requirements, business requirements, and we want to make all of this possible. Even if it's not in Cluster API, we want to give you the tools to make those possible. So sometimes we might say no to things, but we say yes to the 80% use case. And the other 20%, we want to really make it sure that we don't block you, but you can build on top of it. Let's visualize Cluster API a little bit. You have a user over here with a bunch of YAML, because we have a lot of them, and you have a management cluster. We use Kubernetes to run Kubernetes clusters, which might sound a little weird at first, but a lot of users are really familiar with Kubernetes and how, for example, pod works, replica set, machine deployment. And a lot of the types that we'll show you later have this similar concept. They build on the same foundations. Another powerful thing that we like to say is that you can use your management cluster to create clusters in any cloud. And as you can see here, you can manage AWS, vSphere, Google Cloud, and Azure. And these are the most and supported providers that we have today. But where does it fit? At the bottom, you have an infrastructure layer. You have all the clouds, right, that you pay for every month, and then you want to build your Kubernetes clusters on top of it. We have a new bootstrapping mechanism. This project spun off of, say, Cluster Lifecycle, and we worked on kubeadm, and we have seen in the community Talos has had also a bootstrapping mechanism, but also people want to run their custom scripts to build their Kubernetes clusters. And then you create your Kubernetes cluster. But all of this, until today, it's kind of automated, but kind of not, because each cloud provider looks different and behaves in different ways. And we're trying to abstract that out. And then another layer for add-ons. Everything that you want to build and put on top of your cluster kind of builds on cluster. It is separate from Cluster API, but you can add you can add these things on top of it and create your cluster with monitoring, logging, and all of those things. And once your cluster all look the same, it's really, really easy to apply to all of them. And this is where Cluster API comes. It's really a framework. It's not an API, and it's really bad naming, but we separated the two main concepts in Bootstrap providers, which you can see here, that relate on how you bootstrap KubeVM, and infrastructure providers, which actually spin up the VMs, the machines that you can use to create your clusters. So this is another building foundation. That's what we're really building. We're building a framework, an API, foundations for you to use to create clusters in any cloud and make sure that all your business requirements are checked. So where are we now? We're a SIG-sponsored project in SIG Cluster Lifecycle. We have more than 200 contributors, but we need a lot more. We're in alpha stage, which means over time we have breaking things between the alphas, but we're really looking forward to a roadmap to beta this year and deliver in 2020. The V1 Alpha 1 was really the release to get from POC to a version that people wanted to use. Then we learned a lot of things over time, and we made V1 Alpha 2 kind of the solution to those learnings that we had. And we really built solid foundation. A lot of people came to us saying, we want to extend Cluster API, we want to bring in our own Bootstrap provider. It should be easier to build infrastructure providers because there's so many cloud providers out there that we didn't even know about. And so we made sure that extensibility was possible so that you can build on top of this product. And now V1 Alpha 3. This is the release I like the most, even though it's not there yet. We're going to have control plane management, new high-level primitives to manage, for example, auto-scaling group, Azure VMSS, and a lot of quality of life improvements so that new users, when they come in, they're not so scared. We'll have more on this later. There's a lot to talk about here. Where do we want to be? We want to make the cluster lifecycle management boring, really, really boring. We want to have the barriers included. In V1 Alpha 2, as I explained before, we separate the Bootstrap provider out. Now in V1 Alpha 3, we're trying to make KubeADM the default mechanism to bootstrap your cluster, and we're going to ship it with Cluster API. And we want to support a lot of target environments. We want to have kind of like a library of providers that you can use, and you can pick and choose and use one management cluster to own all the providers. And again, support the 80% use case. We say this a lot. We want to make sure that the 80%, for most users, Cluster API should check all the boxes, but we want to make the 20% possible. The advanced use cases is where that will happen. This could be in code, so code that's in or out of Cluster API, more plugins, more extensibility, or really documentation. Some of scenarios that we have seen, for example, for security requirements, different topologies, or more complex scenarios could really be tackled in documentation.
So thanks, Vince. So in this segment of this talk, we will walk through we'll first start by identifying some of the key definitions that will help you kind of follow along and also explore Cluster API. Then we will look at some of the CRDs that make Cluster API happen and work. And then we will finish off by looking at a quick demo. So the first definition that we will look at is that of an infrastructure provider. So this is think of it as the source of infrastructure for your cluster. It can be your public cloud provider if you're in the public cloud, or if you're running in your own data center. This can be VMware or something like Metal as a service. Then we have what we call as a management cluster. So this is a Kubernetes cluster. which you can view as like a single pane of glass to watch over all the clusters in your fleet. And you can also consider this like as a control center to control all the clusters in your fleet. This is also the cluster where we will be storing the CRDs and like where we will be running controllers for these CRDs, which are eventually responsible for provisioning infrastructure. Then we have something called as a target cluster, which is like the Kubernetes cluster whose lifecycle we want Cluster API to manage. When you're looking at some of the documentation, this may also be referred to as like workload clusters. So with that definitions in mind, let's take a look at the CRDs that make Cluster API happen. So this is the cluster CRD. This is one of the core Cluster API CRDs. What I mean by that is this is generic across providers. This is what defines the spec of your target cluster. As you can see from the YAML, I kind of tried to challenge myself not to show any YAML, but here I am. This lets you control the spec of your target cluster. You can use this to configure things like the port on which the API server in your target cluster listens to, like your CIDR blocks for your pods, your services, and all that. And the other key thing in this YAML is the infrastructure reference. So this is the reference to another CRD called the infrastructure cluster. This is the infrastructure provider's definition of a Kubernetes cluster. So this is where you can configure all the infrastructure resources that the infrastructure provider considers as a Kubernetes cluster. So this is an example of an AWS cluster. So here you can provide or you can configure things like your network, like your VPC and your subnets that you want your cluster to be created in and to use, and things like that. It is also possible to bring your own networking and let Cluster API create clusters using pre-existing VPCs and subnets. Moving on, the next CRD that we will look at is the machine CRD. This, like the cluster CRD that we looked at 2 slides ago, is also a core Cluster API CRD, generic across providers. This is what specs out the Kubernetes node in your cluster, right? So this is, again, holds references to 2 other objects, which we will look at again in a closer detail in the following slides. The first is the bootstrap config, and then we also have like the infrastructure counterpart of the machine. First, we look at the infrastructure counterpart of the machine. This is, again, configuring the infrastructure underlying your Kubernetes node, right? So for example, in AWS, this will be your EC2 instance. So you can configure your EC2 instance underlying the Kubernetes node using the CRD. You can specify like the AMI that you want the Kubernetes node to use, the EC2 instance type, the IAM instance profile, etc. For like an exhaustive listing of configuration for this, I would direct you to the Go docs for these types. Now coming to the bootstrap config. So as Vince mentioned, Cluster API prefers or supports the kubeadm bootstrap provider by default. It's like batteries included, but swappable. So far, kubeadm bootstrap provider is what we have as of V1 Alpha 2, and more providers are coming soon. So this bootstrap config provider is the configuration used by the bootstrap config provider. I know that's a mouthful. A bootstrap config provider to generate the necessary metadata or like the user data to bootstrap a machine as a Kubernetes node. So if you're in kubeadm land, this is what this configuration is used to generate the init configuration, the cluster configuration, and the join configuration. The other interesting thing about specific to the kubeadm bootstrap provider is that you can use this to configure the control plane in your target cluster. So what I mean by that is, so let's say you want the API server in your target cluster to use OIDC. So you would use this config to supply the necessary flags to the API server to support OIDC as a means of authentication. So far we've seen like, for the machine level, we've seen like a very low level primitive to control each machine individually. But oftentimes there is a need for a higher level primitive to kind of manage more than all the machines in your cluster. So that is where something like a machine deployment comes in handy. So think about operations like upgrades or updating Kubernetes nodes. Doing it one at a time is hard, and that is where machine deployments can be useful. So continuing with the machine deployment, similar to the machine CRD, the machine deployment also holds two object references. It's the bootstrap config template and the infrastructure machine template. So these are templates used to kind of stamp out Kubernetes nodes based on how many replicas of the machine deployment, how many replicas we've configured in the machine deployment. The other thing about the machine deployment is, as of V1 Alpha 2, we only recommend this for managing worker nodes in your Kubernetes cluster. A higher level primitive to manage control plane is coming soon, as Vince said, in V1 Alpha 3. So far we've seen, like, we've taken a closer look at various CRDs. This is this favorite slide. Or never mind. So this picture should kind of tie it all together. We can see the various, I'm going to try and use the laser pointer. Oh, sorry. I shouldn't. Never mind, I'm not going to experiment with the laser pointer. So we can see the various controllers, like the core cluster API controller, the bootstrap provider controller, and the infrastructure provider controller, all running in their own namespaces. And then on the right, you can see all the CRDs that we looked at and how they are all related to one another. The cluster holds a reference to the infrastructure cluster. The machine has the bootstrap config and the infrastructure machine. And then the machine deployment has the bootstrap config template and the infrastructure machine template. One more thing on the machine deployment is, like, to draw analogies, the machine deployment is similar to deployments in pods. So, and then the machine deployment uses an underlying construct of machine sets, which is similar to replica sets, to manage the underlying machine objects. So with all that, we are ready to look at a demo. This is a recorded demo. That way I can be confident that it'll work. Before I get started, can folks at the back look at my screen? Now? Good? Good? Thank you. So the first thing that we will do as part of this demo is set up our management cluster. We will be using Kind to do that, cluster running on my local laptop. As you can see, this is a brand new Kind cluster on my laptop. The next thing that we will do is deploy the core cluster API CRDs and also the core cluster API controller. As we will see, we created a namespace for the controller manager to run. We defined some CRDs and the necessary RBAC, and we have the CAPI controller manager up and running. Next, we will apply the kubeadm bootstrap provider CRDs and also the corresponding controller. We applied some, we created a namespace, created some resources. Then we have our KubeADM Bootstrap provider running. Now we will do something similar for the AWS infrastructure provider, create CRDs, namespaces, and also the controllers. Okay, now with all these controllers running in my management cluster, I am ready to create my target clusters in AWS. To do that, we will apply some YAML to the management cluster. So the YAML is defining all the various custom resources, and creation of those objects kind of kicks the controllers, all the various controllers into action, and they will all work to provision the cluster for me. So as they work, we will watch the machines go from pending state to provisioned state to finally running state. Now, as you can see, we have all the machines in my cluster up and running. Before we start we are able to use this cluster, we need to apply CNI onto this cluster. We will do that by talking to our target cluster. So one of the things that the controllers did in the process of provisioning the cluster is it created a kube config. It created the kube config for the target cluster as a secret. So what we did here was to interact with the target cluster, we fetched this kube config into a file and set up our kube config to talk to our cluster. And with that done, we are off to the races talking to our cluster in AWS. Now, you only live once. So I'm applying a YAML downloaded from the internet straight to my cluster. And then using Calico as an example here, with that running, our cluster is ready to use. Now we will look at all the nodes in our cluster, in the cluster that we just created. They're all ready. We have a multi-node control plane with 3 worker nodes all ready to run our applications. So with that, I'm going to let Vince tell you what we have in store and how you can all get involved.
All right. So we all know now like how to use V1 Alpha 2. So what's next? What things are we improving? We're doing a lot this cycle, and we're trying to kind of like involve more and more people that have been doing this over time so that we can get even more feedback. The first, which is one ask that we had a lot, is control plane management. This is kind of like a managed control plane in which we work with machines, which we're all seeing, and KubeADM. So and this is also why we're bringing KubeADM not being part of like Cluster API. So you can build and deploy one controller, and that will reconcile like KubeADM machines as well. This effort will also include upgrading Kubernetes versions from one to the other. Today, you could already do that with machine deployments, but upgrading control planes is a different story. And if you had a good experience with that, I would really want to talk to you. The next, this is an effort from Microsoft, and this is Machine Pool. Machine Pool is our abstraction, a high-level type for auto-scaling groups, Azure VMSS, or GCP instance groups. Then we have failure domain. One thing that Cluster API doesn't understand today is where to put your machines. It will let you decide as a user. So there's no way for us to actually just like automatically spread machines over your failure domains. So what we're trying to do is to generalize a concept which a lot of people have strong opinions about in Cluster API. The failure domain concept will go into V1 Alpha 3 as a very basic, but we will evolve it over time so that when we can get more feedback. And this is actually required for control plane management, which is going to go in without failure domains at first, and then we will build on top of it so that we can make sure it works with it. Cluster Cuddle V2. I'll spend a little bit on talking about this. Ashish showed like a lot of like things that we do require like user interaction, applying YAML, a lot of like manual steps, right? And a lot of YAML that you have to create. To create one cluster, you have to create 5 objects. And this is really bad UX. We all know that. But Cluster API is trying to build blocks that you can pick and choose, and then you can use in your own environment. Cluster Cuddle v2, we had a v1 version, which like nobody wanted to use because it's really cumbersome to use. The UX was really bad because it created a local management cluster, first with Minikube, then with Kind, and then it destroyed that cluster and pivoted all the resources, which was a challenge. So the Cluster Cuddle v2 effort, which we're trying to lead forward in v1 Alpha 3, is trying to solve that problem. A better UX, targeting the 80% use case, and just generally improve the user experience. And one note for this is that Cluster Cuddle v2 will also be a library. With VMware, but also like outside, we have seen people that want a like higher level of abstraction. Not too opinionated, but opinionated enough that they don't have to create 5 CRDs, 5 objects to create one machine or one cluster. Node remediation. Red Hat is really working hard on this. The PR is still open. What we're trying to do is to detect failures so that we can replace your machines. Today, well, you have to delete your own machines, and we want to improve that user experience. A testing framework. We had received a lot of feedback over time that people don't really want to use something if it's not really well tested. And if there's PRs that are like continually changing behaviors and like making breaking changes over time, given that we're still in alpha, and those are allowed between our versions, people want to make sure that we're not breaking behaviors. And this happened before, but we're trying to get better. And we put together like a really good proposal, and I think code is going in these weeks that will help write end-to-end tests for Cluster API. So we want to test behavior, scenarios, and kind of like conformance, but we don't say that word out loud, and for Cluster API providers. Validation webhooks. One thing that you can do today is to create any YAML you want, and you can put emoji in it. It will be OK. It will go in. And you have to go and tail the logs to get the failure. Of course, that's not a great user experience. So with, I think, Kubernetes 1.15 and KubeBuilder v2, we're working on validation webhooks. So that when you apply YAML and we cannot validate it, we tell you right away. And that will improve a lot of the user experience. And on top of this, we're also trying to enforce immutability. This is something that people are scared about because every time you have to make a change to your machine, you have to kind of redeploy that machine because we enforce immutability and assume immutability throughout Cluster API. One thing that I want to say, though, to this is that mutable infrastructure is a tough subject, and Cluster API wants to be the best for immutability first. So saying yes to immutability today opens a door to so many other use cases that the project is not ready to take in. But we want to hear from you. So if you have use cases and things, opinions, comments, please bring them and really get involved because we want to really hear more and more on how you're using it. And we will help you. We will help you figure it out, maybe alternative paths or document behaviors that you can rely upon to build your mutable behaviors. And load balancer providers. I kind of learned the hard way that vSphere, some versions of vSphere don't have a load balancer. And so what we're trying to do is to externalize the concept of a load balancer, which now it's created with your cluster object that you have seen before. So for example, if you create an AWS cluster, it would also create VPC, subnets, and a load balancer. Because some cloud providers don't offer, and some, for example, bare metal, you don't have it, you might want an alternative solution to that. And so this proposal, that's linked here, will address that problem. And we'll try to externalize that, and we'll build a POC first, and then see how it fits into Cluster API and how we can make it work for all cloud providers. So get involved. We need a lot of help. And if you have any skills, we're not going to turn you away. Really. I mean it. If you have writing skills, we have to document our book. We tried really, really hard to write a quick start. And that's actually has been really, really helpful, and we got like a good feedback on it, but we need even more. We need to be more specific. I'm not a writer, but I try my best. We need architecture diagrams. So if we developers and maintainers, we can explain to someone that writes like really good architecture diagrams how everything works, we will publish those into our book, and they will be there pretty much like forever. Contracts. So we have seen like infrastructure providers, bootstrap providers, the contracts between these are not very well documented. And we need to do a better job at documenting these. So now they're in code, but we need to take those and make sure that like they're really well documented and people can rely on those. Troubleshooting sections and everything that you can think of. If you find problems in our documentation, let us know, open an issue, and we'll try to tackle that as well. If you have product skills, we need a lot of more use cases. We need good feedback, great feedback. We need to compile user surveys on how people are using Kubernetes today so that we can build a great product. And we need to draw a roadmap. We're trying to do that ourselves, but we're all developers, so we know how that's going to end up. And the roadmap to beta will be a really tough one, but we're trying to compile that for 2020. And you can work with project maintainer to shape the future of this product. You can listen to the community as a whole to kind of get that feedback and put it in our issues, roadmap, etc. And backlog grooming and maintaining milestones. Today, like this is only done by project maintainers, but you can help as well. If you have coding skills, you can start by reviewing pull requests. And over time, you can become an approver, a maintainer of a project. If you know AWS, if you know GCP, Azure, any other cloud provider, if you know them and use them, you can help. And we will make sure that like you have a path to become a maintainer and own that project. You can search for help wanted issues or good first issue if you want to start small, and we will help with that as well. So one of us like is always around on Slack or like at the community meeting, the weekly meeting, and we will kind of like help as much as I can. If you have any other skills, as I said, like come to us. We will try to find something for you to do. Use cases, demos, anything like that. We're trying to build a better community and a really good community around Cluster API. So join our weekly meetings, Slack, the mailing list. We're really active on these things. You find one of us pretty much at every hour. We're spread across the globe. So, and open issues. So if you see something, say something. If something's broken, we want to know. If something's not like right in our docs, we want to know. And if you're bringing use cases or things that you would like to see, like features, please, please, please bring the whys so that we can understand where you're coming from and how to build a better product and how it could fit in Cluster API. Thank you. How are we doing on time?
I think we have time. We are right on time.
We'll take some questions. We'll also be here afterwards.
Yeah, go ahead.
So is there any plan for Cluster API to work with autoscaler so that like you have some way of knowing which node to take down?
So the question was, is there any plans to work with the Cluster Autoscaler project to know like which nodes to take down? So the short answer is there is some work done for V1 which is kind of unsupported at this point from a project perspective. But we want to really work with the project to kind of make sure that the integration works. And we'll draw a roadmap and see how that fits. Any other question over here?
So how would a user of Cluster API cover against change if they lose their management cluster or the bootstrap cluster? And are there any best practices around how you would manage your bootstrap cluster?
So the question is how a user like would know how to manage a bootstrap cluster. Is that correct?
Yeah, and if I
and best
use my
practice.
bootstrap cluster for some reason, right now when you bootstrap a cluster on AWS, you just use the client cluster.
Yeah.
cluster went away, so
Yeah.
how would I recover from the thing?
Yeah, so when we usually like work with people like on management cluster, kind is really not the best way to have as a management cluster, right? Like as you said, like you close your laptop and your management cluster is gone, and then you have this cluster in AWS or GCP or any other cloud that's like living there. So we usually like, and we tell this in the documentation, you can use any Kubernetes cluster. You can use GKE, you can use AKS. I personally will use any of these things if like I want like a long-lived cluster, because it won't be really costly because our processes are like really thin and lightweight, but you can manage it then to any other cluster if you have connectivity.
You could also use Kind to create your first cluster and use that as your management cluster for all the other clusters that you want to create.
So will there be any components that I need to migrate from my kind cluster to the cluster now that I've connected as bootstrap or infrastructure?
So all the CRDs and the controllers that we applied to the management cluster first, you can do the same thing to your first target cluster, which will be your management cluster.
The cluster cuddle v2 effort, like will actually have a way to move clusters around from a management cluster to another management cluster. So if you need to upgrade your management cluster, you can move things around first, and then you can take it down or anything. Any other questions?
Do you guys have any lessons learned as far as how to make it easier for providers to upgrade from V1 Alpha 2 to V1 Alpha 3?
Yes, so the question was from V1 Alpha 1 to V1 Alpha 2, it was a really, really tough migration for all providers. So if you were writing code, like for example, as an infrastructure provider or a bootstrap provider, and you wanted to upgrade that code from one version to the other, it was a lot of work, like weeks worth of work. So V1 Alpha 1, we kind of treated it as like the first iteration of the project. We learned a lot. And going forward, we don't want to have the same experience for providers. We want to make that much easier. So we're doing a few things to solve that problem. The first one, we're adopting conversion webhooks from V1 Alpha 2 going forward, so that when you upgrade, like your CRDs will upgrade as well. We're going to write more documentation how to upgrade. So we have a running doc specifically for infrastructure providers and any other provider that's kind of like working with Cluster API. It's in our doc session. I can share on the Slack later. That tracks all the changes, like literally all of them, like even the one that are like very small. And another thing that we're doing, we're trying to release more frequently. We have been really bad in the past. Before going from like working, like master that wasn't working to a working version, we waited for all the features to be made. This is V1 Alpha 2. Going forward, we're going to release more frequently like alphas, betas of that version, so that you can adopt, but you can also do that like in phases.
For autoscaling, is the path forward going to be going to delegate that to providers using machine pools, or is the plan to have the cluster autoscaler be able to address like machine deployments?
So the question was, for autoscaling, do we plan to only use a machine pool, or is there like any plan to use a cluster autoscaler? The answer is yes, like both of them. Machine pool is much easier from our side because we delegate most of the work to the infrastructure provider. So it's kind of like a lighter effort. But the machine pool with autoscaling groups and things like that will allow for that behavior so that you can autoscale. And there's also plans to use, for example, spot instances in AWS, right, like in the future. The cluster autoscaler, as mentioned before, like it's, we need to have a tracking issues on like how to do that going forward, and we need to work with the cluster autoscaling team so that we can be both successful. Question over here.
Immutable infrastructure is great, but you have a production cluster with, let's say, 500 nodes,
Mm-hmm.
and you just need to apply a little patch for a library. It doesn't
Great question. So I knew this one was coming. The question was, if I have immutable infrastructure, that's nice and great, makes development very easy. But if I have like 500 nodes, then I have to recreate 500 machines. So we're trying to really be good at immutable infrastructure first. The project is trying to be focused on one thing first, and no, it's temporary. Yes, it's forever, right? So we will work with you. Like if you have like use cases requirements to do that in place, we'll make sure that like you're not blocked, and we'll give you guidance to do it like on top of Cluster API, at least for the alpha phases, until we get more and more like kind of like people that can actually contribute. We'll try to make sure that like it works that way. But for now, the project is really focused on immutable infrastructure. 3 questions over here. I'm gonna go.
Normally, controllers in Kubernetes use reconcilable stacks to manage resources. Is there a reconcile notion also again?
Yes.
Could you repeat the question? Like
Is there a reconcile loop in the controllers?
Yes, all our controllers are actually built with KubeBuilder. So every object that you have seen before, it's actually reconciled in its own controller.
What if your management cluster is
It's
gone?
gone. Take backups. That's the first thing I would say. We have a great tool for that.
Yeah.
But other than that, like backups are really like good, and you usually like should take like constant backup. One of the things, as I mentioned before, like Cluster Cutoff v2 will like make you like so that you can actually like move things around. So if your management cluster is dying for some reason, you'll be able to move it to another management cluster. But yeah, so like we also have a way so that you can move resources to the target cluster, so the cluster manages itself.
The other thing
I don't know if it's better or worse, but.
The other thing that I would like to add is like the management cluster is like any other Kubernetes cluster. So all your disaster recovery scenarios or your story should still apply to this cluster.
So there's a chicken egg problem.
Yeah.
Yeah, that's the bootstrap.
We're out of time. Can we take 2 more questions?
Yeah.
Until they kick us out.
So you mentioned Cluster Cutoff 2 a little bit, and today requires kind. So do you think that for Cluster Cutoff 2, we'll remove the dependency on kind and run the reconcile in line, or do you think it'll retain that dependency for kind on the line?
So the question was, is kind going to be required for Cluster Cutoff v2? The answer is no, and that's the short answer. But the long answer is that like we're trying to take an approach that you bring your own management cluster. So you as a user will decide first where do you want to get your resources deployed to in this v2 version. So we're trying to not make assumptions anymore in that sense.
So even today, you don't need kind if you already have a Kubernetes cluster.
Yeah, so cluster upgrades are obviously kind of dependent on how you stood up your cluster itself. So since Cluster API kind of gave that control over to the user, what's the thought process going on around both upgrades there?
Okay. So the question is, for cluster upgrades, there's a lot of things that have to happen before an upgrade happens. And so what is the thought process behind that? So today, for V1 Alpha 2, you can create a cluster and a control plane with just machines. We built an upgrade tool, which is external, which what it would do like all the steps that you would make to kind of like upgrade a control plane, which is remove a node, leave etcd, like all the fun things, and then like add a new node, like join it, and so on. And until the whole process is done, then your cluster is like upgrading. Today that is a CLI. I believe that's still in the VMware org, but we're trying to move that functionality away from there and into Cluster API. So we have a lot of learnings in that. The reasoning behind doing it in Cluster API itself is because, well, we're trying to make it easy and boring, right? Like the cluster lifecycle management. And one big thing is upgrades. So because we know that we're using kubeadm and stacked etcd and machines, we can actually control the lifecycle, all of those, with a new controller that we'll build in Q1 2020.
I think there was one more question.
Yeah, so a typical problem if you sit with the management cluster is that you are managing a certain cluster. All this system can do different versions in themselves, right? You have to do an upgrade. And so does the management cluster upgrade and your actual cluster running app, they do a locking step where you upgrade management first, get support on certain versions, or they are free to go to their own path? So what is the locking?
So if I understood correctly, the question is the management cluster Kubernetes version locked to the target cluster Kubernetes version? Is that correct? Are those two types together?
APIs running on management clusters, are they kind of locking with the versions running on the other clusters?
So the version of the management cluster is actually not relevant for the Kubernetes version that you can run as a target cluster. We have a minimum required version. For example, if we move to CRD v1, the minimum required version will be Kubernetes 1.16. And before that, like I think right now it's Kubernetes 1.13, but I might be wrong, so double check on that. But you can run 1.16 cluster in a management cluster that's speaking 1.13. Yeah. All right, if there is any other question, we'll be around, and thank you all for coming.